Okay, we'll come to chapter 2 for CSF4203. Chapter 2 is actually chapter 5 in the book. Week 1 is chapter 4 in the book. Okay. Today we will talk about data communication, fundamentals of data communication. First of all, last time we talked about analog signal and digital signal. We said that analog signal is continuously changing. Correct? Like a human voice is changing. Okay. Digital signal is changing. It has interval values. Yani it will be like low, but then suddenly high, low, high, for intervals. Okay, intervals. We call them intervals. Okay. Now we talk about the data itself. Analog data and digital data. Who can give me example of digital data?
Video.
Digital data is like binary numbers, 0, 1. Okay. What about analog data, like what? If I have a thermostat here that's measuring the temperature of the room, it is analog data. The readings are analog. Maybe 37 point. لا ما في room 37 like maybe 29, 23, 24. Okay. So data is entities that convey meaning or information. Signal is electric or electromagnetic representation of data. Transmission is the communication of data across a computer network. How? By the propagation and processing of signals. Signaling is the physical propagation of the signal along a communication medium. And let me put this in another way. First, I have the data. I want to send it. How I will send it? I will write the numbers and throw them. I need to convert them into a signal. I convert them into a signal, and then I will find a wire or a transmission line. I will put them in the transmission and do signaling to send them. So this is the communication. First, you have data. You start with data, signal, transmission, and signaling. Signaling is how they are sent. What is the mechanism? We have analog and digital data. Analog data continuous values on some interval can be analog is analog and video. سامعني Mr. Saif?
Yes.
It is video is analog, okay? Voice is analog. Also data collected by sensors such as temperature and pressure meters. Digital data, these are discrete values like text, integers, binary data 01110 like this. And signals are used to encode and transmit data on the transmission line. Okay. How do I put data on the transmission line? This is signaling. What is analog signal? Analog signal is continuously varying electromagnetic wave that may be transmitted over both guided and unguided medium. We already discussed guided, yani cable, fiber optic. Unguided, like what? Wi-Fi, satellite, Wi-Fi. Yeah, very good. So digital signal is sequence of voltage pulses. Generally cheaper. Digital signal is more efficient, cheaper. Less subjectable or susceptible to noise interference. These are all advantages of digital signal. And it suffer more, but however, it suffer more from attenuation than analog signal. Cannot be used on optical fiber or wireless media. You have to know that your Wi-Fi is using analog signal. Fiber is using analog signal. But because the fiber is very fast, it's okay. All right. For analog and digital signaling, this is very important slide. Okay. Here we have analog data. On my telephone, it is encoded into analog signal, converted into analog signal. The modem will take the data from the computer, which is digital, and convert it into analog signal. Modem is abbreviation for modulation, demodulation. Modem, modulation, demodulation. Okay. Now, also, if I have digital signal, if I have analog signal, I use the codec. Codec is abbreviation for what? What? Coding, decoding. Coder, decoder. That's the abbreviation. Coder is actually, codec is abbreviation of coding, decoding. Like modem, modulation, demodulation. Okay? So if I have analog signal, the codec will change it into digital signal. Why? Because my devices are digital. That's why I want to use digital signal. If I have digital data, I want to send it, transfer it into digital signal. That's easy. I use a device called digital transceiver. Transceiver is abbreviation of what? Transmit and receive. Very good. Very good. Okay. So again, we will repeat. See, some slides are repetition. So here we have analog data into analog signal. I use transmitter. I use modulation technique that enables sounds and or video waveforms to be conveyed as electromagnetic waveform over wires or airwaves. اللي هو analog data into analog signal.
That's like cables?
Like the telephone. Telephone. تتكلم انت, you talk to the phone will convert it into analog signal in the wire, the normal telephone. If I have digital data, to convert it into analog signal, digital data like the data coming from my laptop or computer, I will send it over the modem. The modem will convert it from digital to analog and send it over the wire. Okay. But now we don't use modems. Most of the time we are using different kind of internet connection, right? But modem is still used for WAN connections. And then for the codec, coder, decoder takes an analog signal and approximate that signal by a bit stream. At the other end of the line, the bit stream is used to reconstruct the data. Okay. And this is abbreviation of this one. This is the codec. It will take analog signal, convert it into digital signal by taking values of that signal at different times. Okay. Any questions? Now, what is the benefit for this? Why we need to do it? Yani why I have digital data, I use digital signal. Why don't I use just one digital or analog? First of all, I cannot, because I still have digital data and I still have analog data. So I have to be able to transmit. Yeah, I have to be able to use both. Okay. But we have some benefits. If it's not clear here, you can open the PowerPoint also. You see the PowerPoint. Can you read it or not? Yeah, if you have it in the PowerPoint. I think here is better, okay? So here, if I have digital data and digital signal, the equipment for encoding digital data into a digital signal is less complex and less expensive. It's easy. Digital to digital is easy, available. Okay? If I have analog data and digital signal, you need to use modern digital transmission and switching equipment. If I have digital data and analog signal, which we use the modem, some transmission media such as optical fiber, it needs analog. That's why we need to have this combination. As our colleague said, we still need to use analog and digital. If I want to send the output from my computer through fiber optic, I have to convert it into analog. Analog data and analog signal, in the old days, everything was analog. And if you have analog data, it's easy to send it on analog signal, to convert it into analog signal. Now, these are the characteristics of each transmission choice. Analog transmission only transmits analog signals without regard of data content. It does not understand what's inside. Please, you have to know this. Now, your computer, you are dealing with files. You can use search and search what is the file, like some information, a file that has certain words. But for analog, you cannot understand what's inside. The wire will be transmitting, but we don't really know what's inside. Okay. Also, attenuation for analog to overcome the problem of attenuation. We all agreed. What is attenuation? Abdullah. Very good. Attenuation is the signal becoming weak when it is traveling over the cable. Excellent. Attenuation يعني بتضعف مع the signal becomes weak. Okay, we call it attenuation. How do we fix this problem? If I have a long distance and I have analog signal, very good. We use amplifier. Put your hands together, please, for Abdullah. Excellent. Amplifier. We use amplifier. Don't forget this. For analog, we use amplifier. The problem with amplifier, I think in the old days, people used to use it for radios in the cars and sound systems, right? It will amplify everything, even the noise. Even if there is noise, it will be amplified. Okay, that was some of the problems of analog. Okay, you put amplifier, but still it will amplify even the noise, which is not good. For digital transmission, so signal is not evaluated or regenerated. With amplifier, the signal cannot be regenerated, cannot be re-evaluated. So whatever is there is there. Digital transmission, it transmits analog or digital signals. Okay? Remember we said analog only transmits analog. Uses repeaters. Instead of amplifier, it will use repeater. Repeater is a smart device. It will remove the noise from the signal and then regenerate the signal and then send it again a fresh signal. So it's better. Switching equipments evaluate and regenerate signal. Like I will give you one example. The UTB cable, the network cable, Cat5. If I have a device, I have a switch, and then I have a computer around 50 meters, it's okay. But if it is above 100 meters, the signal will not be enough, good, strong enough. So you will need to put a repeater in the middle. If you put the repeater, then you can send it for another 100 meters. Okay. So what are advantages of digital transmission? Cost. Especially if you are dealing with large scale data, bandwidth. Of course, digital is much cheaper. Okay. Data integrity. Effect of noise and other impairments can be reduced. You can control. Remember, we said we can use repeater. Capacity utilization. More, of course. All right. You can share signals, multiplexing on the same wire. Okay. By the way, high capacity is more easily and cheaply achieved by time division rather than frequency division. Remember this, okay? Security and privacy encryption is possible with digital. Integration, all signals you can integrate together. If you have voice, image, data, even telephone calls, you can have one wire. And like now here in the college, I have internet, I have telephone in my office. Yes? Okay. And I have CCTV cameras. In the old days, not very old, I remember this. When? أكثر. 70 years ago. You want me to look very old? Even still now, for some areas, like in military, by the way, in military, I worked in oil company before. We use, for some areas, we like to have dedicated network for each industry. Dedicated network for my telephones, dedicated network for my SCADA, the network for the oil fields, because this is very secret information. Yeah, military, they do this. Yeah. Okay. But in general, you can combine them all because they all use TCP/IP. They are all using TCP/IP. So this is the integration of services. You go to the room, there is one wire for internet, one wire for fire alarm, one wire for CCTV. Okay. Data encoding technique. Analog or digital data must be converted into signal for purposes of transmission. We already mentioned that. Okay. The mapping from binary digits to signal elements is the encoding scheme for transmission. يعني this conversion or mapping into signal, we call it encoding. The basis for analog encoding is a continuous constant frequency signal. We call it the carrier signal. Signal become strong, continuous. You will put the signal on it and send it. Okay. Modulation, the conversion of digital signals to analog form. This is modulation. Demodulation, the conversion of analog data signal back to digital. This is when you send from your computer, the modem will convert it. Then when it arrives, the modem there will convert it back to the computer, to digital. Any questions? Okay. Modulation. Let's do this slide and then we'll have a short break. Modulation of analog signals for analog data. Of analog signals for digital data. Here, this is what kind of data is this on top? This is digital, صح? Okay. Now, there are different ways to transmit it. The first way is called amplitude shift key, ASK. Amplitude, when it is 0, the amplitude, we agreed the amplitude is what? What's the meaning of amplitude? Remember we said the peak? Amplitude, يعني the peak, the amplitude of the قيمة الsignal, the value. Okay? When it is 0, the amplitude is low. We don't know it is 0 or not, it is low. Okay? If there is 1, the amplitude is higher. We have amplitude. 0, it's low. Okay, and so on. So this is the first way, ASK. The second way is, forget about the first BB, يعني binary, okay? Don't worry about it. FSK, يعني frequency shift key. Frequency meaning that if it is 0, I have lower frequency. Very good, Abdullah. Again, put your hands together, please. For Abdullah and Saif. Abdullah and Saif, mashallah. Very good. So frequency, it is low when it is 0. It is high when it is 1. Okay. But what about the last one? We need help from this side. يعني not necessarily you, anybody. Don't worry. The last one, phase shift key. Who can tell me about this? Look it up, no problem. I know you know the answer, Abdullah. خلاص, be careful. Give them chance. Yes. Yes, Hassan, tell us. Very good. Changing the phase or the direction. Put your hands together. MashaAllah, this class is wonderful. I'm good. Changing the phase, the direction. Okay? Changing direction. When it is 0, it is going this side. When it hits 1, okay. Khalas? This is PSK. Usually there is a question in the exam about this. Short answer, multiple choice. You will get a question, trust me. Modems. Now we will talk more details about the modem. I think we said we will take a break. It's okay. Let's take a break. We'll come back. Now we continue.
How we can
Modems continue to be one of the most widely used pieces of communication gear. Okay? It is a device that modulates an analog carrier wave to encode digital information. That's the modem. Also demodulates the signal it receives to decode transmitted information. So coding and decoding, modulation and demodulation. We have different type of modems. Direct broadcast satellite is using it. Wi-Fi modems can be used for Wi-Fi, and mobile phones uses modems to communicate. 3 different types of modems we will study here: voice grade, cable modems, and ADSL. ADSL, I think all of you know it. It's the one used for the house internet. This is a cable modem. So you have the fiber optic cable coming from the ISP or internet service provider. Once it arrives to the home, then you have your cable modem to be connected to the data. All right, so this is a cable modem application. ADSL modem application. Okay. This is a modem connected to the digital subscriber line coming from the ISP. ISP and internet service provider, and your telecom company, like Etisalat or Do. Okay.
By the way, the PowerPoint itself, في كلام بس it's outside.
It will come now in the next slide. I think what you mean, this one.
شوف كيف طالع لنا بالزاوية هنا.
لا, there's an image.
Oh.
Show me, please. Okay. This one you mean? This only, huh?
Two of them actually. Just the difference is that it's barra PowerPoint. That's why the text is outside.
All right. We'll come here. Okay, this is the cable modem. Okay, I know what you mean.
Yeah.
All right. This is your ADSL modem. You have your digital subscriber line, DSL. When it arrives at the home, we have the ADSL modem. We can connect our data, our telephone. Okay. The fastest one is the fiber. Optical fiber is used to, if I have optical fiber cable coming from the telecom provider, and then I have optical splitter, and then I have these optical modems connected to each unit. All right. This will provide the fastest connection. This type of fiber is called fiber to the home. The abbreviation for it is this one. Where is it? Here. This is fiber to the home, or FTTH, fiber to the home, or some people they call it FTTP, premises, fiber to the premises, and to the building, to the block. I'll bring you fiber only to the beginning of the compound.
FTTH and FTTP are the same, صح?
Depends. Premises mean maybe just to the block, to the compound, or maybe to each house. Okay. And maybe I will get fiber to the tower. Inside the tower, I use different. Okay. Okay, now we have very important slide here. Digital signal encoding. Remember before we talked about if I have digital data, how I encode them in analog signal. Remember what are the three methods? Amplitude, shift K, ASK, frequency shift key, FSK, and phase PSK, phase shift key. Here, if I have, yes, of course. I mentioned before the break, I said there will be questions about it, for sure. You can check the recording. Okay. Here I have digital data. I have different methods. The first method is called NRZ. NRZ يعني non-return to zero. Non-return to zero. Okay. Yeah. Let me open this in the PowerPoint. Like what our colleagues mentioned is better here, actually. I think now it's more clear, right? So here with non-return to zero level, L, if it is zero, I have one level. Let's say high. Zero is high. When it reaches one, it will become low. If it reaches zero, high. If it reaches one, low. That's why non-return to zero never will be zero. خلاص, it will be high or low. ما في zero. Okay. The second one is NRZI. NRZI. Non-return to zero inverted. Meaning like toggle switch. Whenever it reaches one, it will toggle. Like push button. One is like toggle. 0, 0, no change. 0, 0, yani low level. When it reaches 1, it will toggle. If it is low, it will become high. 1 again, high will become low. 0, no change. 1, it will toggle. It will become high. We will do an example, don't worry. Here? Here? No, it changed. It was high, it became low. Correct? Here, look here. Whenever it is 0, no change. If it is 1, change. 1 again, change. 0, no change. 1, yeah. This is good method or not? Kind of, very good. Because imagine that someone is sending zeros. A message of all zeros. Let's say 100 zeros.
Nothing will be received.
Nothing will be, and you cannot detect if I am wrong or right.
Yes.
Exactly. Manchester, on the other hand, is better. Manchester, it is changing the value in the middle of the interval. And it's an interval. For Manchester, we are changing the value in the middle of the interval. If it is 0, it will go from high to low. Look here, 0, high to low. If it is 0 again, high to low in the middle. 1 in the middle, low to high. 1 in the middle, low to high. 0 in the middle, high to low. 1 in the middle, low to high. If you do this, you will never make a mistake. Manchester differential, you know, if you start in mathematics, I think you have done differentiation. Yani the differential of it's the opposite of Manchester. You see here, it is filling the gaps. Yani. You see here, it will continue this. It will be the opposite. Yani actually, if I combine these two signals together, what I will get?
The opposite.
0. إذا جمعتهم الاثنين Zero.
Because
Huh?
they-
لأنه it's high and exactly low. Low, exactly high. High, exactly low. But if I add them together, that's why it's called differentiation.
So it
But
intercept each
we will
other.
not ask for this question.
It will intercept each other.
Yeah,
Just-
it will become, if we add them together, but we don't add them.
Yeah.
So we have Manchester, we have differential Manchester. Any questions? There is an example, I will share it with you. It's actually there in the BBL, and I will show after we finish. Okay, analog encoding of analog information. Voice generated sound wave can be represented by an electromagnetic signal with the same frequency components and transmitted on a voice grade telephone line. Okay, that's the normal telephone communication. All right. Modulation can produce a new analog signal that conveys the same information but occupies a different frequency band. Yani we said that my voice, this is that analog, huh? It has different frequency. For a human, we have certain limit of frequency. When it goes to the telephone will convert it into analog signal on different frequency level so that it can be transmitted. Okay. Modulation can produce a new analog signal, as we mentioned. Okay. A higher frequency may be needed for effective transmission. If I want strong transmission covering long area, long distance, I need higher frequency. Analog to analog modulation permits frequency division multiplexing. Analog to analog modulation permits frequency division multiplexing. This is an example. This is analog to analog. My carrier signal is on top. My carrier signal is constant. I have a strong signal. This is my carrier, handle. It will carry the signals, the data. Okay. So if I have different way to do that, I can do the amplitude, also the same thing. Amplitude, if there is a signal, if there is there is value, the value will go, the modulation, the amplitude will get bigger and lower according to the signal, to the peak, because I am carrying it on top. So this is one way. It's called amplitude modulation, modulated wave, AMW. The second method is phase modulated wave. It is changing the phase, changing directions. Okay? It is changing the phase or the direction. What we mean by that is going negative or going positive. The last method is frequency modulated wave. If there is data, the frequency is higher. If there is no data, the frequency is lower. Where is the frequency higher? Which one?
The one that's a lot.
Yeah, a lot of lines. High frequency. Okay. Any questions?
Doctor, how will we get the question? Doctor, how will we get the question?
Maybe they will ask you what are the different methods for conversion, okay, or definition or multiple choice. Okay. Now we have a synchronous transmission. Synchronous يعني what? Synchronized. يعني sender with receiver, they are synchronized.
They work together.
They are synchronized. The timing is fixed together. Okay. So if I want to send, I don't have to tell the receiver, oh wait, I'm send, because we are synchronized already. He knows when I will send, when I will stop. Okay. So synchronous transmission is a block of bits transmitted in a steady stream without start and stop. Why we don't need start and stop? Because we are synchronized.
Stop at the same time.
We are synchronized. Okay. Clocks of transmitter and receiver must be somehow synchronized, very accurately synchronized. That's why for communication, for network, we use nuclear timing, you know, the NTP, if you remember our course. Or yeah, in this course, we will do a lab on syslog, and we will use for timing something called NTP. NTP will provide the time very accurate, using nuclear watches or clocks in certain places of the world. Okay, don't get scared, yani. Just I'm talking about the timing. It's very accurate timing. Okay, and we don't rely on Big Ben watch.
Yes.
It has to be very accurate in milliseconds. Why? Because the network speed is very high.
It's fast.
And we agreed last time, I told you the speed of signal is how much? It's the same to the speed of light, which is
300,000
kilometers per second. See? So if there is a 1 second difference, big problem, yeah? Big problem. So the data plus preamble, postamble, and control information are called a frame in the data link layer. It involves the use of a data link control procedure which automatically detects transmission error and causes a frame in error to be retransmitted. This is in the synchronous transmission. Error control process is very important for communication because we said before there is noise, we get some errors. So in your system, you should have some mechanism for error control. Okay? All transmission media have potential for introduction of errors. So all data link layer protocols, so the correction is happening in the data link layer. Data link is which layer in the OSI? Data link layer. Very good. Second layer. صح? تمام. Data link layer is second. Even in the TCP IP, data link layer. Okay. We have from top application, session layer, presentation, transport, data, internet or network, data link, and physical. For the TCP IP model, which layers we have?
We have
Physical, media access, internet, transmission, application, 5 layers. Some books, they say 4 layers. Okay?
most application only says also 4 layers. Most application when you use it says 4 layers.
Yeah. To the according to the book. Here for our book, I think it's 5 layers. Okay? So we have 2 things. We have error control process has 2 components. First, excuse me. We have error detection, so you need to detect if there is an error. And then you need to correct. And correction for transmission is very limited. What is the correction in transmission? What do we do? Yeah. What do we do?
You fix the frames.
And if I receive a frame and there is some problems, the computer will open the frame, what is the problem, and fix. Retransmit. It will request to retransmit. So this is the method for correction. It will request retransmit. Okay, so the error connection receiver and transmitter cooperate to retransmit frames that were in error. Allah. Tamam? Yani this is some people like to ask about the exam. For exam, they will ask you what is the error control process in transmission. Okay. How do I check for errors? There are different ways. Allah. Parity check. What does it mean? Who knows about parity? Parity. Yes. You want to help us? Okay. Parity is, what is parity? What is odd or parity? Odd or even? So parity, I will make sure that, okay, I am receiving a frame. I know that my frame that I receive should be odd or should be even. If I receive even, then there's a problem. Okay. So when you are sending, bit is added to each character to make all bits add up to an even number. We call this even parity. Or odd number, odd parity. But this is very premature way of sensing errors. Why? Because if I lost 4 bits or 2 bits, it's the same, even. صح? If I lost 2 bits or 10 bits, still even. The computer will not know you lost 2 bits or 10 bits. Yeah, it is. It's limited. Used but limited. Okay. So it's good for detecting single bit error. Noise impulses are often long enough to destroy more than 1 bit. So these are the disadvantages of this method. The ability of parity checking to detect errors is dependent on the total number of bits corrupted by noise impulses and the parity convention that is used. Okay. So if I'm using just parity check, I will not know exactly how many bits were deleted or lost. Okay.
Do people still rely on parity checks more often?
You should rely on other methods also. Okay, some methods are in the application layer. You have some software that will check. Because nowadays computers are very fast. So we can do the checking on the application itself. So here we have a summary of this chapter. Part of the chapter, okay? So we have digital to analog signal. We are using, this is a summary. I think this is very good. Who was asking me, Yani? For digital to analog signal, I can use encoding, which is ASK, FSK, PSK. The device is called modem. For example, this is very important slide, by the way. Read it, please. Take your time.
Doctor, in the digital, what does 4B and 5B is? Like, what's that encoding scheme is? The 4B and 5B.
We are not studying it. This is all, yeah. We care about differential Manchester, NRZ L and NRZI. That one was taught before, but خلاص. Okay.
We talked about PCM.
Just you need to know that there was a method 4B and 5B.
And we speak about PCM or no?
It used to be, we used to teach PCM. PCM is actually, if I have analog signal, I want to convert it into digital representation. I'll use a technique called PCM. There is a chip even. PCM stands for what? Pulse coded modulation. How does it work? Who can tell us? It's not needed for the exam. You just need to know that you take values. I don't know, maybe you are lucky this year they will ask about it. Usually they don't ask.
Wait,
Maybe you are luckier than other students.
because it's not the part.
If you have a signal, it will take values for the signal every 10 milliseconds, 10 milliseconds. And then it will convert it into binary.
I think this is used also in hospitals. This method.
For what?
When you're checking their heartbeats and
Yeah,
stuff.
maybe, yeah, to send, yeah, they can, yes, to send it as binary, no problem. Okay? So to get accurate representation, what is you are supposed to do? You are supposed to take more samples. So, I'll give you one example so that you will not forget this. Okay? If I look at this road every day at 10 a.m. No, not here, the road, the main road. Okay? At 10 a.m. in the morning, we will see that there is traffic.
Yes.
Maybe we have what? 20 cars there. And then I will keep track. Khalas, I know that if I do like this, every day this road has 20 cars. Is this accurate?
No.
No, because you took your sample only one time. But if I take sample every hour, then I know that 10 a.m. is high traffic. Maybe 5 p.m. is less traffic. So the more samples I take, the more accurate. Same thing with PCM. Okay? Halas? Don't mention this example in the exam, yani about our road, university road. Any questions? This is the summary. You are welcome. I will stop the recording.